This question asks about three identical boxcars. There they are. Draw yourself a simple diagram. Each of them have some mass, and they're cruising along with a velocity v. They collide with another boxcar. So there's another boxcar. And the question is, what's the speed of the four cars? Now, you know what the speed of the three cars is. You don't know what any of them weigh, but you do appreciate that they're going from 3 to 4 cars. So they're going to couple on. And conservation of momentum says that that momentum doesn't change. So the momentum before and after the coupling will be the same. So the momentum before is equal to the mass times the velocity. Momentum before. And the mass here in this case is 3 boxcars. The mass after the collision, momentum, again, let's remember the definition of momentum, mass times velocity. The momentum afterward, we don't know what that velocity is going to be, so I'll call this velocity before, velocity before. But 4 boxcars is going to move along with some unknown velocity, velocity after the collision. And if momentum doesn't change, these two momentums are going to have to be equal. So if you appreciate how much, now even if you don't know exactly how much momentum before, you can compare, and if these two are equal, if there's the same unknown on both sides, which is the mass of the individual boxcars, that can cancel out. You can also calculate kinetic energy before and after. Now, of course, conservation of energy says that also energy doesn't change, but energy can take on may have many different characteristics. Energy could be in any one of several categories, including kinetic energy, including heat energy. So there is no such thing as a conservation of kinetic energy generally, but you can still, from the definition of kinetic energy, which is mass times velocity squared, 1/2 mv squared, you can compare kinetic energy before the collision and kinetic energy after the collision, because you should be able to track changes in mass and changes in velocity.